Okay, so this is day 8 for the second distance learning packet and the math section. All right, so our task is a Pythagorean Theorem task, and we have a couple of drawings here, and we have to answer these 3 questions. So let's take a look at the drawings first. The left one is just a triangle. The right one has squares attached to each side of the right triangle. And a couple things. So we're talking about Pythagorean theorem. So we are talking about right triangles. So these are all drawn on gridded paper. And gridded paper has right angles where those lines intersect. So we know that those are all right angles. Okay, which is very important. We have to have a right triangle in order to use Pythagorean theorem. And then as a reminder, Pythagorean theorem is shown at the top right of this page. Okay, A says to explain why the quadrilateral sharing one side with the hypotenuse of the triangle is a square. So I'm just going to draw over that just so we know which one it is. So it is this figure here. So that is a quadrilateral, 4-sided figure, and we want to know why it is a square. So I'm going to answer this without really even using Pythagorean theorem. I don't really see the need to use it. So let's just take a look at what's going on here. I'm going to break this up into triangles. So remember, in order to be a square, so what does that mean, a square? So remember, squares have equal side lengths and 90-degree corners, right? Vertices. So if we can show those two things, then it's a square. Okay, so let's take a look at this figure here. Let's draw in 1/4 of this square. So it's the same as our right triangle, okay? And we've learned a few things with triangles and also with parallel lines. So we're going to use all that to prove that this is a 45, or this is a square. So this is a right triangle. Okay, so remember the angles in any triangle add up to 180 degrees. Okay, so this is kind of like a proof that you're going to do similar thinking as you're going to do in high school. So here we have an angle and another angle, and they are exactly the same. Okay, so I'm sure we already know what those angles are. Think about a square. So these grids are squares, right? So those are 90 degrees. If we cut that angle in half, then how much is on each side? 45 and 45, right? Yeah, that's exactly right. So let's take a look at the triangle that I just drew. So we know that this is 90 degrees. Okay. And then, so this is 90 degrees. And then these two are equal. So I'm going to call this x and also call this x. So I have x plus 90 equals 180. Let's see if we get the same answer this way. So this is 2x plus 90 equals 180. Subtract 90 on both sides. I get 2x equals 90. Divide by 2. I get x equals 45. So each of those angles is 45 degrees. Okay, so if this is 45 and this is also 45, because they're all the same triangles, then each of these corners of the square is 90 degrees. Okay, so we just proved that. So all of the angles are 90 degrees. All right, so that's one part of our definition. And then the other one is equal side lengths. Okay, so we can actually calculate the side length using Pythagorean theorem, which we will have to do to find the area. Okay, so let's just do that. So if I'm looking at the top left, I'm gonna do that in green. So I'm gonna just make another right triangle, okay? So this is side length of 1, this is side length of 1, then what is this? And then if we look at the red triangle that we drew first, it also has side lengths of 1 and 1. And then we could break that all up. So every triangle inside of the square, they're all the same, right? So these side lengths, whatever they come out to be, will all be equal. Okay, so I'm just gonna do one of those because we're gonna actually need it again. So our Pythagorean theorem, a squared plus b squared equals c squared. So let's use that to find the side length. So a is 1 squared, so this is a squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared. 1 squared is 1, 1 squared is 1, so I get 2 equals c squared. Okay, to undo that square, we need to take the square root. So c equals the square root of 2. Okay, so square root of 2. Square root of 2 is 1.41. Let's just say 1.41. So it's about 1.41. Okay, so that's the same. Going back to our drawing here. So this is 1.41. This is 1.41. This is also 1.41. Okay, so there's a lot more we could talk about, but if we show that, that'll be enough for 8th grade math. So 1.41, all the sides are equal. So we just proved that. Equal side lengths, and we showed that they all have 90-degree angles for each of the vertices. So that's it for A. Okay, so B, find the areas of the 3 squares in the picture. Okay, so I'm actually just going to highlight one of these. So here's 1, here's 2, and then that one we just did, we've been looking at. So we're going to get the areas of each of those. Okay, so the area for the orange one, the sides are 1 and 1. Okay, so what's the area of a square? Area of a square equals the side times itself, or side squared. So the area equals 1 squared, or just 1. Okay, if we look at the green square, it's exactly the same. So the area is also 1. Okay, so then how about the area of the red one that we did? So the side area equals side squared again. So area equals, what do we find? Is about 1.41 squared. Okay. So when we square that, because we rounded it, so 1.41 times 1.41, we get 1.988. So it looks like it's almost 2, but it actually is 2 because if we, instead of rounding, using this rounded answer, if we did this, so what is the real answer? It's just the square root of 2. And if we square that, well, square root and square cancel each other out, so we get area equals 2. Okay, so that's it. So those are the areas. So we have an area of 1 for each of the small ones, and then an area of 2 for the larger ones. Okay, and then last part says, is the sum of the areas of the squares on the legs equal to the area of the square on the hypotenuse? So basically, the orange and green, if we add those areas up, will it equal the area of the red? And yes, we can see that if we take 1 plus 1, we will get 2. So this is this one, this is this area, and here's this area, and 2 equals 2, which is true. So basically, it's just a way, we did a similar thing in class, a little bit different triangle, but we did show that the 2 smaller squares, when we add those together, they will equal the larger square. And so our Pythagorean theorem is just that. So the length of A, okay, if we draw a square on here, so that's A squared, that's the area, okay, plus the area if we draw a square over here. So those two areas added together will equal the area of this larger square. So we did this in class, but this is kind of a visual proof or visual understanding of Pythagorean theorem. Okay, moving on. We need to find the distance between 2 points on a graph, and we're going to use Pythagorean theorem to do that. We're going to round our answers to the tenths. Okay, so that tells me we're going to need a calculator. Of course, your phone can do it, I believe. If you turn it sideways, you get a scientific calculator that has square root. So what we need to do is make some triangles in order to use Pythagorean theorem. So I'm going to do just one of each type and let you do the rest. So the first one, I'm going to finish off my triangle. It has to be a right triangle. And it is a right triangle if we're using the grids. Okay, so we need to know the side lengths. So this one is 2. This one is 5. Okay, so a squared plus b squared equals c squared. So we're looking for side C, the distance between those 2 points. So 2 squared plus 5 squared equals c squared. 4 plus 25 equals c squared. 29 equals c squared. Take the square root of both sides. So square root of 29 is 5.385. We're going to round it to the tenth, so it's going to be 5.4. So this is 5.4 is approximately C. So we rounded it, so that's why we have the squiggly equal sign. So it means approximate. And that's it. Okay, the next section, we actually need to graph the points first and then do the exact same thing. So graph the point first, so 4 comma 5. So 1, 2, 3, 4, comma 1, 2, 3, 4, 5. So there's a point there. Then it's 0, comma 1, 2, 3, 4. So there's our side C, and then we need to make the legs. So this is 1 and this is 4. Okay, so again, same formula. We're looking for C. So we have 1 squared plus 4 squared equals C squared. 1 plus 16 equals C squared. 17 equals C squared. Take the square root of 17. You also have that in your notebooks. 4.1. So 4.1 is our length. So remember, just kind of mental check. Side C is always the longest, so whatever answer we get should be longer than the legs. So 4.1 is longer than the longest leg of 4. And then the first one that we did, the longest leg is 5, and our answer was 5.4. So it is longer, so it does make sense. Okay, so the rest of that, I will leave it up to you. Again, show your work wherever you want. It doesn't matter if it's messy. If you need to add another piece of paper, that's fine, but try to fit it on this page if possible. Okay, here we have, I believe this is our final section, and we have a word problem. Okay, and I'm going to help you solve it, and then I'm going to leave the rest up to you. Okay, so the total cost of 3 gift cards and 4 movie tickets is $168, while 2 gift cards and 3 movie tickets cost $116. Find the cost of 1 movie ticket. Okay, so we can use a system of equations. That's the first thing that I think of. But if we don't want to solve this using equations, let's maybe just kind of reason it out. So I'm going to draw this. So we have the first piece of information says 3 gift cards. So I'm just going to do gift cards, so 3 of those. And 4 movie tickets. I don't know. These are tickets. Okay, so those are 4 movie tickets, and that's $168. Okay, so the other situation says we have 2 gift cards. oops, gift cards, plus 3 movie tickets. And that equals 116. Okay, so just read it again and make sure we got everything. Nope, we made a mistake. So the first one is 3 gift cards and 4 tickets. That's 168. The second one is only 2 gift cards. So I added 1 extra. So 2 gift cards and 3 movie tickets, and that's $116. Okay, so we need to know the cost of 1 movie ticket. So here's a ticket. So how much does it cost? All right, so let's think about this. If we look at these 2 different situations, let's think about so we know that 2 of these, along with 3 of these, so this kind of set is 116. So that means if we have, so 1 gift card plus 1 ticket, that would equal, so what's the difference between 168 and 116? So if we subtract that, so 168 minus 116, we get $52. Okay, so $52 is the price for 1 gift card and 1 ticket, right? So just think about that for a moment. Okay, again, I know that this bundle, let's just call it a bundle. We have 2 gift cards and 3 tickets. It's $116. So that's this, right? That's the same 2 gift cards, 3 tickets. That amount is $116. So then we just have a gift card and a ticket that's not part of that. So whatever that is, it has to be able to add to 116 to make our total of 168, which is $52. Okay, so now let's think about this. Here we can make a new kind of bundle, okay, a gift card and a ticket. We know that those together equals 52. We want to find just the cost of 1 ticket. Okay, so let's go back to our second scenario here. So here's a bundle. So that's 52. Here's another bundle. That's 52. So this is what we're looking for. That's our answer. Okay, so can we figure this out? So if I have a 52 and a 52, so these 2 bundles together would be $104. So whatever's left out over, that must be the price of a movie ticket. So 116 minus 104 is $12. So this is $12. And that's the answer. So 1 movie ticket. Okay, so a movie ticket costs $12. So that's one of many ways we can solve this. We could have looked at the first piece of information and made our 1-in-1 bundle like this, like this, like this, and then we would have that ticket left over. So it'd be 3 of those bundles. So let's just do that kind of in our head. So if I take $52 times 3, so 3 of those bundles is $156. And if I subtract 156 from 168, I also get $12. Okay, so it's the same answer. So thinking back to our systems of equations, remember it doesn't matter which equation we use to find our final answer. It's kind of like it doesn't matter which situation we used here. So hopefully it kind of like makes sense when we look at the algebra part of it. So anyway, this seems kind of messy, but keep in mind we didn't use any equations, no real formal algebra here, just kind of drew it out, we thought it through, and we found our answer. So this is a strategy you can use on any test question too. So if it doesn't say it doesn't tell you what method to use, then you can use any method. Again, you can use equations if you like. I can write that out. I'll just write it off to the side, just for those of you that would rather do it that way, and then I'll erase it. So it's 3, I'm going to use G for gift cards, 3G plus 4T equals 168, and then 2G plus 3T equals 116. So again, in order to use elimination, we would have to kind of adjust both of these equations. If you want to use substitution, it gets a little messy, but it definitely can be done. So if you're into that, if you want to know more, you can send me a message or stick with the kind of visual solution that we did. Okay, that is it for this day.